Okay, so today we are talking about what are called relations. I'm going to talk about relations. The definition of a relation is very simple. A relation is a set of ordered pairs. It's a set of ordered pairs. For example, i.e., that means for example. I make my bracket to start my set, and I'm going to use the set 1, 2, 3, 0, 4, 5, and 7, 6. That is my relation that I'm going to use. Okay? Now, by the way, do you know what an ordered pair is? Okay, you can talk in this case. We are live. Okay, so I'm sure you know an ordered pair. You've graphed before. We've all graphed before. I'm sure in 6th grade, your teacher gave you a list of ordered pairs, and you had to graph each ordered pair, and then connect the dots, and it made a wabbit.
Yep.
A wascally wabbit. Okay, so this is what we call a relation. Now, a relation, besides being made up of ordered pairs, we have to kind of look at the ordered pairs a little bit more in depth. So I'm going to have you help me with some of this stuff. And matter of fact, let's do this. Oh, there we go. Let's rewrite down our relation. So our relation was 1, 2, and then what did we have? 3, 4, 3, 0, sorry. 3, 0, 4, 5, 7, 6. Okay, so that was the relation. Now, the next thing we're going to talk about, I want to see if I could do something here. It's not going to let me do that. Come on. There we go. Copy. All right. So, the first thing we're going to talk about here is what is called the domain. It's the domain. Not domain, computer domain, or things like that. This is just a domain. The domain is basically the set of all x coordinates. The domain is nothing more than the set of all x coordinates. The way we write the domain is very simple. We make a D, a capital D, that indicates domain. We put a colon, and then we make our set notation. Anytime we do like that funky little bracket there, that indicates that a set's about to come. And in this case, I want the set of all x coordinates. Can somebody give me an element, that's what we call parts of a set, an element of the domain?
1.
1 is in my domain. What else is in my domain?
-1.
-1 is not in my domain.
2.
2 is not in my domain.
3.
4 is in my domain. I'm going to leave a space because you skipped one. What else is in my domain? 7 is in my domain. What else is in my domain?
3.
3 is in my domain. Is there anything else in my domain?
No.
No. So I will end my set. That is my domain. It is the set of all x coordinates. That will become important later on when we talk about something called a function. Yeah, because they're fun. Shuns. Yes, okay. You guys are getting the hang of this. The next thing, paste it. Cool. That went really big. That's okay. So that's my, what is that? That's my relation. That's my relation. Now, the next topic we're going to talk about is called the range. Do you know what the range is? What do you think the range is?
For which numbers it goes?
Huh?
From which numbers the set?
No.
Oh, Y coordinate?
Well, we could say that, but actually the range is where the deer and the antelope play. You know, home on the range. Okay, I'm not singing on video. But I know. But yes, you are right. The range is the set of all y coordinates. Now, I am kind of shocked, and maybe some of you would have done it. The word range actually has two meanings in math. One of them is the set of all y coordinates. Oh, look at all the hands going up. Too bad you can't see them. What are all the hands? What is the other thing for the range?
The difference between the highest and lowest number.
The difference between the highest and lowest. When do we use that particular range? I'm trying not to use names on video, so.
Okay. The data set, when you have a data set.
In statistics, when you have a data set. But this is not a data set. This is a set of ordered pairs. So that's why we use the range this way. But we'll make an R. We'll make a colon. We'll start our set. And can somebody give me an element of the range? Yes. 2 is definitely an element of my range. Give me another one. 0 is an element of the range. Give me another one. 5 is an element of the range. And I need one more. Everybody. 6. Thank you. 6 is an element of the range. So that is the domain and the range and what a relation is. Now, there we go. We are going to use this when we have our discussions about ordered pairs and relations and a little bit more about it. Now, let's back up for a second and make sure that you have some other terminology down. I want to introduce you, we're going to take a trip, actually. And this trip is on, we're going to take a trip on a plane. Yeah, we're going to fly. Yeah, Coordinate Airlines. Traveling to 4 quadrants daily. Hey, laugh nicely on video. Okay. The coordinate system, or as sometimes referred to as the coordinate plane, okay, is used to locate points. Now, that's really kind of a bad word to use. But the points have very special names, and they're known as what? Okay. I stand shown. Okay. They are known as, starts with an O. Ordered pairs, thank you. Dots. Oh my, okay. Let's look at a coordinate plane. Get it? The coordinate plane? I bet some of you drew that.
I did.
The coordinate plane. The coordinate plane is made up of two lines. It is made up of two lines. Can someone tell me what the horizontal line is called?
The x-axis?
It is called the x-axis. And then we have the vertical line, and the vertical line is the y-axis. Oops. The y-axis. So we have the x-axis and the y-axis. And when we're talking about this particular coordinate plane, we're actually talking about a two-dimensional coordinate plane. We could go three-dimensional, but then we would be talking about a z-axis, and we're not going to get to that yet. That will come into play later. But I'm not... No, we're not going... Okay, so the x-axis and the y-axis intersect at one of those special dots. Okay, ordered pairs. What is the name of that ordered pair?
Origin?
It is called the origin. That is right there. And this is called the origin. It's the beginning of everything. It's where you start. It's at the origin. What is the ordered pair for the origin, by the way? Okay, everybody.
0, 0.
Good. So we actually do understand that the ordered pairs, and I'm going to actually move to a new screen here. Hold on. So everyone understands that an ordered pair is a point that is labeled with an X and a Y, with an element of the domain and the element of the range. Okay. So it is an X and a Y. We do that. And the X coordinate corresponds to how far over we go on the X-axis. And the Y coordinate corresponds with how far we go up or down on the Y-axis. On the Y-axis, good. Now, we are going to be, for this particular lesson, we are going to focus, well, let's back up for a second. Let's back up. Let's draw our coordinate grid again, or our coordinate plane. Because we have two lines intersecting, those two lines create 4 areas. Those 4 areas are called what? Anybody know what those 4 areas are called? What are those 4 areas called? Quadrants. This is known as quadrant I. Exactly. Nope, quadrant I. It is quadrant 1. It is a Roman numeral. We do name it with Roman numerals, and it is very important that you do keep it with Roman numerals to avoid confusion with other things we will do with the coordinate plane later on. But that is, in fact, quadrant 1. How many quadrants are there?
4.
There are 4 quadrants. The question is, where is quadrant 2? Is quadrant 2, now you tell me, if this is quadrant 1, is this quadrant 2? No. Is this quadrant 2? No. Is this quadrant 2?
Yes.
Oh, no. That's quadrant 2. Good. This is quadrant 2, or II. This is quadrant 3. And this is quadrant Ivy. Yes, it's a bunch of leaves growing out of the ground.
Oh! I get it, yeah.
That's the other one. It's poisonous in that quadrant. Now, all right, now, tell me something. Think about the ordered pairs, all the ordered pairs in quadrant 1. Because all the ordered pairs in quadrant 1 actually have something in common. What do all the ordered pairs in quadrant 1 have in common?
Both the domain and range are positive.
Good. We call it the positive quadrant because both the x and the y will be positive. What about quadrant 2? What about quadrant 2? What do we know about it?
Negative, positive.
Okay, it's negative, positive. I call it the winking quadrant.
Oh, I see. It looks
I
like
just
a
three
nose.
So, what can you tell me? What can you tell me about quadrant 3?
It's negative.
Yes, it's the sleepy quadrant. Negative, negative. And what about quadrant 4? What about quadrant 4? Yes, it is. But what is it? It is. It's positive, negative. Positive, negative. And it is another winking quadrant. So all the ordered pairs in there are going to be there. All right. So for our discussions today in particular, we are going to focus on quadrant 1. We are just going to focus on quadrant 1. So let's draw quadrant 1. Now, when you draw your graphs, ladies and gentlemen, it's very important that you're very careful on how you draw your graph. Because you want to make sure that everything is nicely done and neatly done. And honestly, personally, if I was going to do this assignment, I might go get a piece of graph paper and tape it into my notebook because it will help you to be organized, though you don't need to. Some of you might even get graphing notebooks. You don't need to go do that right now, but you can make a graph as so. And we break it up, our graph, into equal segments on the x and y axis. When we number those segments, please note that you must use what we call a uniform scale. Most of the time it'll be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and I ran out of room for 6. But you must do it in a nicely organized way. Could you do it by 3s? Could I go 3, 6, 9, 12, 15, 18?
Yes.
I could. Not as nice, but I could. Could I go 1, 2, 5, 12, 18, 36, 92? No. It's why not?
It needs to use a pattern.
Yeah, it's not uniform. It doesn't follow a specific pattern. So in this case, you have to follow a specific pattern. If I was to give you the point, say, I don't know, let's do 3, 2. How would you graph the point 3, 2? How would you graph the point 3, 2? Go ahead and do it on your paper. Pause the recording. Right, so, if I was going to do 3, 2, if you did this correctly, you would have started at the origin. And we always start at the origin. We always start, in this case, we're going to start if we're doing an ordered pair, and I'm very careful about saying it that way. For doing ordered pairs, we always start with our x. We move over 1, 2, 3 spaces. Then we go up 1, 2, and then we could mark our ordered pair 3, 2 in the right spot. How many of you got that correct? Yeah, every hand better be up this time. Okay. If I did this for you, let's see if you can see that. If I did this, could you tell me what ordered pair that was? Could you tell me what ordered pair that was? Oh, who hasn't answered something yet? Close. Close. It's 5. It's actually not up to the 4. It's 5, 3. It's very hard to tell, and that's why a lot of times we want to use graph paper, because otherwise it's all over the place and we can't really tell where it is.
It's 5 and 3.5.
Okay, we're not going to get, yeah, you're right. We could get very technical on that, but we're not going to. All right. Just know that with this I have, what did I want to say about that? We can graph it. The toughest thing to graph, by the way, is when you start getting into fractions and decimals and how you actually get to that, because you can't get precise. You could if you wanted to, but you have to be careful. Like, for example, I could say, oh, look, this is 1.5. But if I do that there, I have to do it everywhere. So, a lot of times we don't want to start doing, all that extra stuff because it really could cause issues in the long run. So, today in class, what you're going to work on is page 34, numbers 12 through 33, and 37 through 39. And then tonight, you are going to watch the video on section 1.7, which will be on words, equations, tables, and graphs. Okay, I will see you tomorrow.